Now I'd like to solve the equation 4x minus 5 all squared plus 48 equals 0. So the thing to be on the lookout here is notice we have a squared term. Don't even worry about the 4x minus 5 right now, but we have something squared and we have a constant involved in this equation. So this is going to be an equation that we can solve using the square root property without having to factor or use the quadratic formula, some kind of more time-consuming methods. This one we can solve a little easier. And again, you can use this square root property to solve when your equation involves a squared term and a constant, which is all that's really involved here. So we should isolate the squared term in this case, and let me start to color code this. Looking for my blue marker. Okay. So we've got this quantity 4x minus 5 all squared equals the constant negative 48. So once you have your equation in the form something squared equals a number, then you can solve that equation by taking the square root of both sides. Just remember that there are two numbers that you can square to get whatever you had here, so we need to put a plus or minus. For example, there's two numbers that you can square to get 4, 2 and negative 2. So we need to put a plus or minus in front of the square root. Well, you can put it on whichever side you want. We traditionally actually put it over here, where we took the square root of the number. So let me just show it here. So it's a little sloppy over there anyway. So we've got something squared equals a number. We take the square root of both sides, but take plus or minus the square root of the constant over here. So on the left side, we're doing inverse operations. We have the second power, we have the square root. Those are inverse operations of one another, so we end up with just the 4x minus 5 that was inside, because the second power and the square root undo each other. So we have 4x minus 5 equals, okay, here's something to think about. So for now, I'll write it as plus or minus the square root of negative 48. But we need to simplify that radical expression. And so this is something you practiced in the previous section, and so now you get to use that skill. So let me do a little scratch work off to the side over here on the square root of negative 48. So first of all, it's the square root of a negative number. So square root of negative 1, remember, is I. And then times the square root of positive 48 now. Now also remember, the trick to simplifying expressions like this is to identify a perfect square that is a factor of 48. And ideally, we want to identify the largest perfect square that's a factor of 48. So if you think about your perfect squares, so 2 squared is 4, 3 squared is 9, 4 squared is 16, then we got 25, then we've got 36. Okay, at this point we know this is bigger than anything that's going to divide evenly into 48. Notice 16, if you wrote this as 4 times 12, that's okay. You can work with that. But the quickest way to reduce these expressions is to identify the largest perfect square that divides evenly into 48, and that's 16. We can write 48 as 16 times 3. And then the square root of 16 is 4. The square root of 3 is ugly, so it stays under the radical. I'm sorry about the glare there. But so the square root of negative 48 right here is equal to 4i square root of 3, according to that scratch work that we just did. Okay, so let me copy down the rest of this. Oh, the black marker's drying up a little bit here. Equals plus or minus this quantity here. Now what we need to focus on is isolating x. So in order to isolate x, I could add 5 to both sides. I'm already going to go ahead and think about writing my final answer in standard form, which means we put the real part first. So I'm going to add 5 to both sides. I'm going to write that positive 5 in front. And that's fine, as long as you keep the correct sign on everything. So this is positive 5 and then plus or minus 4i squared root of 3. And then last step, so in order to isolate the x, I need to put these markers down, I can divide both sides by 4. So that'll get the x by itself. I'll write the final answer over here. Now, you may want to cancel the 4 right here, and that's fine, but make sure you divide both parts by 4. So if you do that, you need to write 5 divided by 4 plus or minus, and then sure, 4i square root of 3 divided by 4, and so there the 4's would cancel. So you could write your final answer as 5/4 plus or minus I times the square root of 3. And that would have your answer in standard form for a complex number.